Hello, everyone. At the very first, I'd like to thank the organizers to invite me here. Let me introduce you to myself. My name is Ilyasur Rahman from Department of Computer Science and Engineering in Dhaka International University, Bangladesh. My other co-authors, my other co-authors are Khandakar Mohammad Mohiuddin, Raunak Burhan, Fateha Sharmin, and Shoikot Islam Khan. The title of our paper is a Dangerous Landslide Suspectable Region Forecasting in Bangladesh, a Machine Learning Fusion Approach. Today, I'll be talking about problem statement, objective, related works, dataset, proposed method, result and discussion, and conclusion here. Problem statement. A landslide is defined as the movement of a mass of rock, debris, or earth down a slope. Landslides occur when a gravitational and other types of shear stresses within a slope exceed the shear strength of the materials that form the slope. It causes many people's death and other losses. Objective. By using machine learning technique, the proposed landslide identification method will be showed outstanding robustness and great potential in tackling the landslide identification problem. There are some related works around it. Guzetti et al., Zhang et al., Chen et al., Naidu et al. Declared that landslide identification plays an important role in landslide risk assessment and management. Zhang et al., Larry et al., Zhang and Go, Pioneer, Straub, Ching, and Fung showed that machine learning and deep learning techniques have been proven to be a powerful and promising tool in many geotechnical applications. Li et al., Lu and Liang proposed a CNN-based approach for forecasting landslide. Barlow et al. Showed landslide identification are mainly based on optical images using pixel-based or object-oriented methods, and the digital terrain models is often used as an auxiliary data for such analysis. Research goal. In order to map landslide suspectability for some of the areas in Rangamati district, Bangladesh, this study compares and evaluates a variety of machine learning models, including random forest, support vector machine, naive Bayes, random forest, logistic regression, decision tree, and hybrid approaches. Dataset. The Rangamati district is in the southeast of the Chittagong Hill Tracts. It is 6,116.19 kilometers square in size. It is between latitude of 22 degree and 27 minutes and 23 degree 44 minutes north, and the longitude of 91 degree 56 minutes and 92 degree 33 minutes east. There are 2,43,999 persons living in the research region, of whom 48% are Bengalis and 52 are tribes. There are 97 individuals per kilometer square, and male to female ratio is 1:1, BBS 2011. The research region is 70.939 meters above the sea level on average. Rabi et al. Used the Rangamati landslide dataset, and this dataset is actually used in this experiment. Dataset. There are some metadata in the dataset, like aspect. An aspect map shows both the direction and grade of terrain at the same time. Curvature. Planned curvature refers to the outlines on the topographic map or the curve of the slope in a horizontal surface. Earthquake. In the event of an earthquake, the ground surface may shake and vibrate because of the propagation of seismic waves. Elevation. For the assessment of landslide vulnerability, elevations are frequently used. Elevation differences may be attributed to different environmental conditions as rainfall and plant species. Flow. Landslides known as flows occur when fluid-like material slides down a slope. Lithology. According to the results of several research, lithology significantly affects the regional variances of landslide prevalence, kind, and depth. NDVI. The RS readings are analyzed and normalized to difference vegetation index NDVI. A straightforward graphical indication is frequently used to determine whether or not the target being examined includes green healthy vegetation. NDWI. Surface water features can be distinguished using the normalized difference water index. Plane curvature. The curvature of a slope is a horizontal plane, or the curvature of the contours on the topographic map is referred to as plane curvature. Profile curvature. The maximum slope's direction is parallel to the profile's curvature. Negative value depicts an upwardly convex surface at that particular cell. A position profile shows that the cell's surface is concave upward. Slope. Hillsides can have straight contours known as planar zones. Convex outward plane curvature known as noses, and concave outward plane curvatures known as hollows. Landslide debris congregates in hollows near the slope's base in a small area. Landslide. This metadata indicates the landslide risk, nothing else. Data processing. The raw data will be proceeded in two stages. The first stage is to derive landslide-related predictors from the raw data. The second stage is to transform the data to a machine-readable format. Methodology. This methodology is used in our paper. Here, our data is collected, then the data is pre-processed. Then the features are selected to use the machine learning model. Then some machine learning model using some regular machine learning model and hybrid models are used to find the best machine learning model to find the landslide suspectability. Then the finding the best model accuracy and mean absolute error is very lethal to our method. Then the data is predicted. Experiments and results. The experiment is carried out on a local computer using Jupyter Notebook, NumPy 1.0.1, Matplotlib, Scikit-learn, and Pandas. Based on the experiment, two different sets of results have been analyzed. This experiment used different machine learning algorithms, including a decision tree, a random forest, and a Gaussian naive Bayes. After pre-processing the data and selecting features to apply, SVM surpassed other machine learning classifiers with an accuracy of 75.99%. Then to improve the accuracy, this study used a fusion method of machine learning algorithms. This experiment shows that this study uses naive Bayes, decision tree, and random forest, and decision tree, and linear regression, decision tree, and Gaussian Bayes together to find the best solution. Experimental results, accuracy measurement. The confusion matrix has 4 outcomes that evaluate each classifier's performance on position, positive and negative classes separately. These outcomes are true positive, false negative, true negative, false positive. Following equations help to calculate accuracy, precision, recall F1 score, and sensitivity of the machine learning algorithm. Experiment and results. performance of the different machine learning algorithms. Here we can see a bar diagram of different machine learning and fusion approaches in our data set, in this data set. Here we can see the best accuracy has been found in a fusion approach in random forest and linear regression model. Here we can see the accuracy, F1 score, recall, and precision and sensitivity of different machine learning algorithms. Here we can see that random forest and linear regression fusion created an outstanding 91.1 accuracy model with a 0.81 F1 score, 0.84 recall, 0.85 precision, and 74% sensitivity. Experimental results, comparison table among various approaches of finding landslide prediction. There are many papers which we used various approaches to predict the landslide suspectability. Here we can see that only our approach, fusion approach of linear regression and random forest, we got 91.1% accuracy. Conclusion. One of the most difficult jobs in geohazard assessments is mapping the vulnerability of slides. In this study, a novel fusion strategy of a prediction model is used to analyze the susceptibility to landslide in Rangamati, Bangladesh. Various triggering conditions and historical landslide data were used to feed the model. The suggested land machine learning fusion model outperformed a wide range of benchmark approaches and provided accuracy of 91.1%. The statistical analysis and presentation of the predicted data show that Bangladesh's hillside faces a serious risk of landslide. The study's findings can be utilized to prepare in advance for any potential landslides in the southeast of the country. So the study has the potential to save innumerable lives as well as the general public's wealth. Here are the references which were used in our paper. Thank you very much.